Whatever shade your skin is right now, it is not the original color of your species, not even close. Every single ancestor you have, going back roughly 300,000 years, had dark skin. No exceptions, every one of them, until relatively recently. And here's the part that should actually surprise you. Recently doesn't mean tens of thousands of years ago. In 2018, scientists sequenced the DNA of a skeleton found in an English cave, a man who died there roughly 10,000 years ago. Bright blue eyes and skin closer to black than to the pale color most people picture on an ancient European. His direct cultural descendants are walking around England right now, pale enough to burn after 12 minutes in the sun. Something happened between him and them, and it happened far faster and far stranger than almost anyone assumes. It involves a vitamin made from sunlight, a completely different vitamin that same sunlight destroys, and one single ancient mutation that gave a very specific trait to every person who's ever had it. Let's go find out exactly what happened and why it happened so late. Start with what skin actually is, because most people treat it like packaging. It's not. Skin is your largest organ, and one of its biggest jobs, running constantly, is managing radiation, specifically ultraviolet radiation fired at Earth by the sun every single day. UV light carries enough energy to physically damage DNA. It breaks chemical bonds inside your cells, and damage like that, left unrepaired long enough, can eventually turn into cancer. The pigment that colors your skin is called melanin, and melanin in the most literal sense is sunscreen, built in, always on, no reapplying required. More melanin means darker skin, and it means more UV blocked before it ever reaches the DNA underneath. In equatorial Africa, where our species began, under some of the most intense sun exposure on the planet, that protection wasn't optional, it was survival equipment. But here's where most simple explanations of this quietly fall apart. For decades, scientists assumed cancer prevention alone explained dark skin. There was a problem with that. UV-related skin cancer usually shows up later in life, well past the age most ancient humans had already had children. Evolution doesn't reward traits that only help after you've already passed on your genes, so something more urgent had to be driving this, something tied directly to reproduction. In 2000, anthropologist Nina Jablonski at Penn State and her colleague George Chaplin published the answer in the Journal of Human Evolution. UV radiation doesn't just damage skin, it penetrates into blood vessels near the surface and destroys a B vitamin called folate. Folate is essential for something called the neural tube, the structure in a developing embryo that becomes the brain and spinal cord. Without enough folate in the first weeks of pregnancy, sometimes before a woman even knows she's pregnant, that structure can fail to close properly. The result can be severe defects or miscarriage entirely. So there were two separate reasons dark skin got aggressively favored in Africa. Melanin protected DNA from UV damage, lowering cancer risk over decades, and melanin protected folate specifically during pregnancy, protecting reproductive success directly. One threat plays out over a lifetime, the other plays out in a matter of weeks inside a body, whether anyone's aware of it or not. Two separate biological problems solved by exactly one trait. In equatorial Africa, dark skin wasn't just useful. Genetically speaking, it was close to mandatory. Which raises the obvious next question. If dark skin is this efficient, this thoroughly proven across hundreds of thousands of years, why doesn't most of the planet still have it? The answer starts the moment your ancestors began walking away from the equator. Somewhere between roughly 70,000 and 60,000 years ago, groups of Homo sapiens began leaving Africa for good. Slow generational drift. One group walks a little further than their parents. Their children walk further still. Over thousands of years, this spread people through the Middle East into Europe across Asia. And as they moved further from the equator, something about their environment quietly flipped. The sun itself didn't get weaker. It's exactly as intense as it's always been. But at higher latitudes, sunlight hits at a much lower angle, passing through far more atmosphere before it reaches skin at all. Days get shorter. Winters stretch on under overcast skies for months. Instead of relentless radiation you need to block, you suddenly have weak seasonal radiation you desperately need to absorb. And the exact same trait that had been mandatory in Africa turned into a liability. Not because of cancer and not because of folate. Both of those pressures actually eased up. The problem was something almost nobody gives proper credit to: vitamin D. It's synthesized directly inside your skin using UVB as the energy source. Your skin is quite literally a solar panel. Without enough of it, calcium doesn't get absorbed properly, no matter what you eat. In children, severe deficiency causes rickets, which softens bones badly enough to bow the legs and flatten the skull. In adult women, deficiency can soften the pelvic bone specifically, making childbirth dramatically more dangerous. Picture a heavily melanated person living in Northern Europe roughly 40,000 years ago. Their skin blocks UV brilliantly, perfect near the equator, but it can't tell the difference between dangerous UV worth blocking and scarce UV they now desperately need to absorb. It just blocks, automatically, every time. Vitamin D synthesis drops, bones weaken, children develop rickets, reproductive success quietly declines. So evolution, one more time, simply followed the math. Random mutations that reduced melanin kept appearing, the way mutations always do. This time, instead of getting filtered out, they spread. One gene shows this almost perfectly. It's called SLC24A5. A single letter change in this gene accounts for somewhere between 25 and 40% of the total skin tone difference between Europeans and West Africans today. One gene, nearly half the visible gap. It likely originated in one single person somewhere in West Asia, around 19,000 to 28,000 years ago, and swept outward from there, reaching close to 90% frequency across early European farmers. Here's the twist that surprised the researchers themselves. That gene doesn't explain lighter skin in East Asia at all. They evolved similarly pale skin, using almost entirely different genes. Two populations arriving at nearly the same visible outcome through two completely separate genetic routes. Biologists call that convergent evolution, and when it happens this cleanly, it's one of the strongest signals biology can give you, that a pressure was real.
For a long time, the assumption was that all of this happened slowly, over the full span of tens of thousands of years. Ancient DNA has completely wrecked that assumption, which brings us back to that man from the beginning of this video. Researchers name him Cheddar Man, after Cheddar Gorge in Somerset, where his skeleton sat in a museum for over a century before anyone could read his DNA. In 2018, a team led by Dr. Selina Brace and Professor Ian Barnes at London's Natural History Museum sequenced his complete genome, the oldest fully sequenced British genome that had ever existed. Dark curly hair, startling blue eyes, skin the team described in their own words as dark to black. Chris Stringer, the museum's research leader in human origins, called it genuinely surprising, and he'd studied that exact skeleton for over 40 years. Modern British people share roughly 10% of their ancestry with his population, which means widespread pale skin across that region only really took hold in the last 6,000 to 8,000 years. Out of a 300,000-year species history, that's under the final 3% of the entire timeline. Something specific must have sharply accelerated the process right around that window, and it did. The Neolithic Revolution, the switch from hunting and gathering to farming. Hunter-gatherer diets were naturally rich in vitamin D, fatty fish, organ meats, shellfish. Farming diets were mostly grain, supplying almost none of it. Dietary vitamin D intake didn't decline, it collapsed. People became almost entirely dependent on whatever their own skin could still manufacture. If that skin was still relatively dark, that suddenly wasn't nearly enough. On top of that, farming communities were dense and settled, and dense populations spread a beneficial mutation far faster than small wandering groups ever could. Diet collapse plus population density hit fast forward on a trend that had already been running quietly for tens of thousands of years. Quick one, if this kind of deep dive is worth your time, subscribe. It genuinely helps. Now, back to the story, because this next part is the strangest fact in the whole video. Blue eyes. Every single person alive today with blue eyes, without exception, is descended from one specific individual. Before that person existed, every human eye on Earth was brown. In 2008, geneticist Hans Eiberg at the University of Copenhagen traced the trait to a single mutation in a gene called OCA2, somewhere near the Black Sea. His estimate placed it between 6,000 and 10,000 years ago. One mutation, one person. Every blue-eyed human on the planet traces back to them. A trait people think of as ancient is, in evolutionary terms, almost brand new. Step back now and look at the entire shape of this story. Skin color, the one trait used throughout history to sort people into hierarchies, is, at its actual biological core, a UV calibration dial. Nothing more mystical than that. Your body's best inherited estimate of exactly how much sun protection it needs based on the latitude your distant ancestors happen to live under. Light skin isn't better in any absolute sense. Drop it back near the equator and it becomes a genuine liability. And dark skin isn't the more primitive starting point either. It is the original human condition, the baseline every other version modified. Here's the part that might be the strangest twist in the whole story. The exact same sun that forced some populations to build more melanin also forced other populations to shed it at the exact same time. The sun never picked a side. It just radiated with total indifference and let evolution sort out whatever kept the most people alive to have children. Here's a real question, and I genuinely love your answer in the comments. Does it surprise you more that this changed this recently, or that it changed this fast once it actually started? Tell me down there. I read every one of them. And if this changed how you'll picture ancient humans from now on, tap like before you leave. So next time you look down at your own hand, understand what you're actually looking at. Not a fixed trait handed down unchanged since the beginning of time. A living record written in melanin, folate, and vitamin D of exactly which latitude your ancestors gambled on and how the sun decided to treat them for it.